Okay, this is Module 6, Lesson 20, Problem Set, or the Concept Development. So what we're going to do is analyze this problem, this word problem, and analyze the data that goes with the word problem to see if we can answer the questions. So before we really get going, you need to look at the data that you're being presented. What data are the graph or the scenario communicating? What is this graph telling us? What information and what units are shown on the axes? So why don't you go through and start to label things and break things down? Figure out, how is this broken up? Figure out how this is broken up. What is this trying to tell you? What is this trying to tell you? All right, come back and see if you've completely labeled and figured it out. All right, so did you label your axes, x-axis, y-axis? Did you label your origin? I noticed this right here, this little blurb right here. Then I noticed there's weeks and there are pounds. This is 6. So before 6, there's like this little drop off. There's nothing really going on here. Then it's 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, right? Then, so this is weeks. How many weeks are going by? Then we have pounds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are how many pounds of, looks like right here that it's tomato. Notice that your graphs are always labeled with a title. So it's total tomato production. All right, let's read the problem. The line graph below tracks the total tomato production for one tomato plant. So this is just one tomato plant. The total tomato production is plotted at the end of each of 8 weeks. Use the information in the graph to answer the questions that follow. So let's go back to this sentence. The total tomato production is plotted. That means it's plotted at the end of each of 8 weeks. So we're going to use how many weeks, how many pounds were in production. So at 8 weeks, it looks like it's 3.5. 3.5. And then at 8.5 weeks, it's just a little bit past 4. At 9 weeks, it looks like they have 5 pounds of tomatoes. So what I want you to do, I have 4 questions for you. Based on the graph, how many pounds of tomatoes did this plant produce at the end of 13 weeks? So you have to go at the end of 13 weeks, how many pounds of tomatoes did this plant produce? Now, part B, how many pounds of tomatoes did this plant produce from week 7 to week 11? So remember, how many from here to here, how many pounds of tomatoes did this plant produce? Explain how you know. Explain what you did to solve that. How many pounds were produced? C, which 1 week, so 1 week period, so that means a whole week from 7 to 8, right, showed the greatest in tomato production? Where was the greatest growth? Where was the least amount of growth? So remember, based on what we learned, the lesson from yesterday and looking at the rain charts, what did we use in order to solve that problem? And then explain how you know. Then part D, during weeks 6 through 8. So weeks 6 through 8, from here to here, Jason fed the tomato plant just water. During weeks 8 through 10, 8 through 10, so from here to here, look at that. Look at the difference from 8 to 10, 8 to 10. Look at the growth. So from here to here, just used water. From here to here, he used a mixture of water and fertilizer A. So from here to here, he used water plus a special fertilizer. And weeks 10 through 13, he used water and fertilizer B on the tomato plant. Compare the tomato production for these periods of time. So comparing, 6 to 8, 8 to 10, and then 10 to 13. Which strategy did he use? Which one was the most effective? So Jason fed from 6 to 8 just water. Then 8 to 10, he used a water plus a fertilizer A. Then in weeks 10 through 13, he used water plus fertilizer B. So which one had the best results based on the data here? I want you to go through and I want you to answer A through D and then come back to check your work. All right, so hopefully, and notice I wrote out my answers. I just didn't write one word or two words. How many pounds of tomatoes did this plant produce at the end of 13 weeks? The plant produced 10 pounds of tomatoes at the end of 13 weeks. So 13 weeks, 10 pounds of tomatoes. I didn't just write 10. So I explained it. How many pounds of tomatoes did the plant produce from weeks 7 to week 11? Explain how you know. The plant produced 6 pounds of tomatoes from week 7. It had 3 pounds at week 7 and it went up to 9 pounds by week 11. The difference is 6 pounds. 9 minus 3 is 6 pounds. Question C. Which 1 week period showed the greatest change in tomato production? What was the least? And explain how you know. Week 9 to week 10 was the greatest change. 9 to 10. Do you see how the slope goes from 9 to 10? Do you see that growth? How the line goes up? It is flat between weeks 11 and 12. That means it didn't make or grow any tomatoes then. It just was flat. Just flat. It didn't do much. Now, during weeks 6 through 8, Jason fed the tomato plant just water. During weeks 8 through 10, he used a mixture of water and fertilizer A. And in weeks 10 through 13, he used water and fertilizer B on the tomato plant. Compare the tomato production for these periods. So, looking at the graph, it appears that the water helped tomatoes grow. So just the water helped tomatoes grow. But the fertilizer A seemed to make the most growth with the water. So water plus fertilizer A had 5 pounds, and water plus fertilizer B didn't seem to improve or help the growth of tomatoes. So he should keep the water plus fertilizer A. All right, so you understand the expectation, right? And how you should be answering these. So, problem B. Use the story context below to sketch a line graph. Then answer the questions that follow. So here we go. The number of fifth grade students attending Magnolia School has changed over time. The school opened in 2006 with 156 students in the fifth grade. The student population grew the same amount each year before reaching its largest class of 210 students in 2008. The following year, Magnolia lost 1/7 of its fifth graders. So 1/7, that sounds like something multiplying. In 2010, the enrollment dropped by 154 students and remained constant in 2011. For the next 2 years, the enrollment grew by 7 students each year. So what you're going to do is break this problem apart. So it opened in 2006 with 156 students. So then the next part of the problem is the student population grew at the same amount each year before reaching its largest class of 210 students in 2008. So your first question is plotting a point at 2006. Then from 2006, 2008, that is what you're working. This is the area. Then part 2, what you're working on. Then part 3, the following year, Magnolia lost 1/7 of its fifth graders. That's part 3. Part 4, in 2010, the enrollment dropped by 154 students and remained constant in 2011. So 2010, 2011, that's part 4. Finally, part 5. So you have 5, you're plotting points in 5 different in increments. For the next 2 years, the enrollment grew by 7 students each year. So up until 13. So from 2011 to 2013, that's what you're going to be plotting then. All right, before you get started, Magnolia School, 5th grade enrollment. All right, so we do this every year at Hankey as well. Then these are the years that we're talking about. And here are the number of students that you're going to be plotting. So I guess this means that we're not worried about the data underneath it, that we're recognizing there's data underneath that, but we're not working with that. We're starting here. All right. So this is just part 1 of this problem, is just plotting your points inside the graph. Part 1 of the problem. And it has 5 steps, 5 data points. How many more fifth grade? Then part 2 of this problem, how many more fifth grade students attended Magnolia in 2009 to 2013? So then you're just reading the graph. Between which 2 consecutive years was there the greatest change? Using the graph. If the fifth grade population continues to grow in the same pattern from 2012 and 2013, based on what you know, based on the graph, in what year will the number of students match 2008's enrollment? So remember, there was a 1/7 here, taking what is 1/7 of the population. All right, so what you're going to do is you're going to start out by doing the first, you're going to plot 1, 2, 3, 4, and 5. You're going to plot those 5 points, find those places on the graph and plot them. And then you're going to come back and check your work before you even attempt A, B, or C. Now remember, before I send you off to practice and try this out on your own, Here are the years. So 2006. So it looks like from 2006, do you see that? There's like a half a year in between here, right? And then if this is 150 and this is 200, how is this chart? How is this broken up? So remember, this is 150 and that's 200. So what is that even? What are those lines? How can you solve that? What is the increments that are going? Is it 60, 70, 80, 92? Oh, no, that's not going to do it. I wonder if it's broken up like this one is. 150, 160, 170, 180, 190, 200. It's got to be that. So 160, skip, 170, skip, 180. No, that's not it. I wonder how we're going to figure that out. Does it tell you? Just go back to the top here. Does it tell us how this is broken up? Okay, I want you to use your reasoning skills and I want you to try to figure out how that is broken up. Now, see if just looking at the data and trying to plot the points helps you figure that out and come back and check your work. Okay, before you answer any of the questions A, B, or C, were you able to label this? It goes up by fives. 150, 155, 60, 65, 70, 75, 85, 90, 95, 200, 205, 210. All right. Knowing that the greatest amount has to be 210. All right. So 156 to start off with. 210 at its highest, dropping by 1/7, 1/7 of 210, then down to 154 in 2010. Then it remained constant in 2011. And then for the next 2 years, the enrollment grew by 7 students each year. So 154 plus 7, 161 plus 168. 161 plus 7 is 168. All right. Now that you have your graph completed and filled in, now you have your data. Now you can use your data to answer the questions. So part A, how many more fifth grade students attended Magnolia in 2009 than in 2013? Looks like a subtraction problem to me. Between which 2 consecutive years, consecutive means right next to each other. 1 plus 1 is consecutive. Consecutive years was there the greatest change in student population from like 2006 to 2007, 2007 to 2008, 2008 to 2009. Consecutive means it goes together. So it's only 2 consecutive years had the greatest change in student population. In the 5th grade population, if the 5th grade population continues to grow in the same pattern from 2012 to 2013, in what year will the number of students match 2008? How you're going to be doing something to figure that out. All right. So now I want you, now that you've checked this and made sure all your data is correct and figured out how we got there, remember it's 1/7 of what operation do we do? Yes, you're going to multiply 1/7 times 210, right? All right, come back and check your work for A, B, and C. All right, so let's check your work. So how many more 5th grade how many more 5th grade students attended Magnolia in 2009 than in 2013? It's a subtraction problem. There were 12 more students in 2009. Between which two consecutive years was the greatest change in student population? Well, between 2008 and 2009, it decreased. The school lost 1/7 of or 30 students in its population. This was the greatest change. Now, if the fifth grade population continues to grow in the same pattern as in 2012 and 2013, in what year will the number of students match 2008's enrollment? So, starting out 2008, it was 210. In 2013, it was 168, which is a difference of 42. 42 divided by 7 is 6. So 2013 plus 6 is going to give you 2019. All right, so 2012 to 2013, 7 students each year. If the student population continues to grow in the same pattern, the population will reach 210 by 2019. All right, that is it for concept development. Part of your exit ticket, you already have the data. Can you interpret the data? Can you tell me, answer these questions? Then, for homework, you already have the information in your graph. You're going to answer the questions. They're on 2 pages. And that is it. That will do it. So you can come on back for the problem set debrief after you've spent a good solid 15 minutes trying to complete your exit ticket, but most importantly is your problem set.